In this video, we will learn why Delhi faced frequent earthquakes in 2020. 16 earthquakes or so were recorded in the Delhi NCR region from April this year till June 8th. Although the magnitude of these earthquakes were minor and light in nature. The Richter magnitude scale is a scale of numbers used to describe the power or magnitude of earthquakes. Delhi, the capital city of India, is bounded by the Indo-Gangetic alluvial plains in the north and east. In the west, you will find the Thar Desert, and in the south, you will find the Aravalli Hill Ranges. If you look at this map, in this you can see how the entire country is divided in different seismic zones. Delhi falls under Zone 4. Though it may not fall in the highest seismically active region of the country, the city can still face disastrous consequences if any earthquake strikes with its epicenter anywhere in the surrounding areas such as Hindu Kush mountain range or the Himalayas. First of all, you have to understand that it is impossible to predict an earthquake. You can only record data and find out the epicenter of the earthquake, but that is not going to help you in predicting when the next earthquake is going to come or from where it is going to come. However, there is a general as well as larger prediction that all the earthquakes recorded in Delhi NCR region are due to the release of energy through the faults that exist deep in the Earth's crust, when the Indian plate collided with the Eurasian plate some 40 to 50 million years ago. So let me begin from that story and then slowly step by step come to the present scenario. You all know the story, right? Some 40 to 50 million years ago, two large land masses, India and Eurasia, driven by plate movement, collided. Always remember, when you break down different layers of the Earth's surface, we have the inner core, the outer core, then the inner mantle and the outer mantle, and finally we have the crust. Now Earth's crust is further divided into two types, oceanic crust and continental crust. And just below the oceanic and continental crust, there is a thin layer of upper mantle which is very similar to Earth's crust. The whole of crust and the thin portion of that upper mantle is together known as lithosphere. It is the solid outer part of the Earth. The lithosphere includes the brittle upper portion of the mantle and the crust. Together it is the outermost layers of the Earth's structure. So right below the lithosphere, there is a layer of upper mantle called the asthenosphere. This is made up of molten rock. It is much hotter and the entire layer can move like fluid. So what happened was around 225 million years ago, India was a large island situated off the Australian coast and separated from Asia by the Tethys Ocean. The supercontinent Pangaea began to break up 200 million years ago, and India started a northward drift towards Asia. 80 million years ago, the Indian plate was 6,400 kilometers south of the Eurasian plate. It was moving towards north at a rate of between 9 to 16 centimeters per year. And how was it moving? At that time, Tethys Ocean was subducting. That means an oceanic plate was moving under the large Eurasian continental plate. If I have to say this in a more technical sense, the asthenosphere, which is a layer of the upper mantle that was moving towards the northern direction, and that too moving right under the huge Eurasian plate. When this oceanic plate was moving under the large Eurasian continental plate, it was also pulling the Indian plate, which is attached to it. When this was happening, there was a lot of explosive volcanic activity that was taking place on the Eurasian plate. Also, a lot of ocean floor sediments was being pushed onto the Eurasian continent. These scraped off sediments are what now form the Himalayan mountain range. This accumulation of ocean floor sediment onto a continent during subduction is called accretionary wedge. From about 50 to 40 million years ago, the rate of northward drift of the Indian continental plate slowed to around 4 to 6 centimeters per year. Now this slowdown is marked as the beginning of the collision between the Eurasian and Indian continental plates. In other words, the closing of the former Tethys Ocean and the uplifting of Himalayan mountains were taking place. As soon as the Tethys Ocean was sealed up, both the Indian as well as the Eurasian continental plate crumbled and started folding. That's what created the Himalaya and the Tibetan Plateau. You have to understand that these continental plates at an average were around 75 kilometers thick. When such a thick continental mass collided, just imagine the intensity behind it. This kind of massive impact had also shut all the volcanic vents around this region. If you look at the type of rock that are found in Himalayas, you will find granite. And we all know granite is basically formed when magma solidifies. Anyhow, the crashing of both the continental mass has sealed all kinds of volcanic activities around that region so that it does not reach the surface. We also know that the Himalayas are still rising 1 centimeter per year as India continues to move northwards into Asia. Now before I go further, I need to go back to the point where the continental plates at an average were around 75 km thick. When they collided and crumbled, that's how the Himalayan mountain were formed. Now I want you to imagine what happens when two thick blocks of landmass collides and crumble. It will develop deep fractures, cracks and fault line. Some of it you may see it on the surface, while some of them might be hidden in deep layers of the crust. Now if you understand this, let's go to the regular map and let me show you the main Himalayan fault line. We have all read that the Himalayan mountain ranges consist of 3 parallel ranges: the Greater Himalayas known as Himadri, the Lesser Himalayas called the Himachal, and the Shivalik Hills, which comprises the foothills. So all you need to do is locate the Shivalik Hills from northwest extension to the eastern extension. You will find Shivalik Hills in lower districts of Himachal Pradesh, Uttarakhand, Nepal, Sikkim, Bhutan and Arunachal Pradesh. Now below the Shivalik Hills, you will find the Gangetic Plain, and in the eastern part, you will find the Brahmaputra Plain. That means the Shivalik Hills are the boundary line of Himalayan mountains. If I have to make a rough measurement from the foothills to the Greater Himalaya, the distance will be somewhere around 200 kilometers. That means the collision of the Indian plate and the Eurasian plate caused ripples on both the landmass. But if you look at the Indian plate, the ripples went some 200 km backward, because that's where the Shivalik Hills are. And after that, plain areas begin. You can also call this boundary as Himalayan Folded Belt. Now there must be so many fault lines in the deep layers of the crust that branches out from this Himalayan fault line or Himalayan Folded Belt. Some of the well-known fault lines near Delhi are Mathura Fault, Moradabad Fault, Delhi Haridwar Ridge, Delhi Sargodha Fault, Mahendragarh and Dehradun Fault. These are just few discovered ones. There are many more such fault lines which are not yet discovered. So the existence of such fault lines make this region vulnerable. Because if you look closely, these faults and fractures are held by rock layers. When enough stress builds up and the rocks deform or crack, break or suddenly slips, the entire block of land which was resting on it suddenly slips and drops. It releases energy in waves that travel through the layers of the crust and causes the shaking that we feel during an earthquake. Plus we also know that the Himalayas are still rising by 1 centimeter per year as India continues to move northwards into Asia. So any of these fault lines that exist in the deep layers of the crust may release energy anytime, even due to minor northwards shift. We cannot predict it, and that's what makes us feel the tremors. These fault lines exist near plate boundaries. They are very long and they run very deep.